Hey math kids, today we're going to talk about differentiation from first principles. And to start off, we'll start with some notation. So you'll remember from the last video, f prime of x means derivative. Also some new notation, dy dx, dy over dx. And this is equal to the limit as h approaches 0 of That's similar to what we used in the previous video, except for I changed the a's to x's, so we know that it's not just a specific point, but maybe it's all the points. And so what a derivative function can tell us is if we plug in a3 to the derivative function, it tells us what the slope of the original function would be at x equals 3. And so it can be powerful sometimes to know the slope everywhere on a function rather than just one point. Okay, so that's kind of what we're going to talk about. Now also, we're asked to find these derivatives using first principles. The reason why it's worded that way is in a lot of cases, that's not what I wanted. A lot of cases there's shortcuts, but this one is asking us not to use shortcuts. So we can understand it conceptually. So what we're going to do is we're going to start with this, and we are going to apply this to this. So we have x plus h in our f of x, and so I'm going to write this as x plus h quantity squared. So I'm plugging in x plus h for the x. Minus f of x, so we just write it exactly as we see it, and that's all over h. And this is the limit as h approaches 0. Now we try to plug in that limit, but it creates division by 0. So hopefully we can create something on top that cancels that h. That's our approach. Now we want to expand this piece, and we can't just distribute the squared. Instead we need to do x plus h times x plus h. And so we do x times x is x squared. X times h is positive xh. H times x is positive xh. And h times h is h squared, and then we subtract x squared. That's still over h, and we're still taking the limit, but our limit doesn't work yet. So we notice that these cancel each other. We notice that these combine to 2xh, and then we still have our h squared. Once again, we still have division by 0, so I'm not going to write my limit yet. Okay, we can take out an h from each piece. And the h on top and the h on bottom cancel. Now we can take the limit as h approaches 0 because there's no division by 0. We plug in 0 for h, and we end up with just 2x. So in other words, f prime of x is 2x when f of x is x squared. Okay? All right, let's move on to the next one. So this time we're going to start with x to the 4th. And then we need to find f prime of x, or find the derivative. Okay, so they want us to do it from first principles. So we're not going to use any shortcuts. So I'm going to just say limit as h approaches 0 of, I'll just write the whole thing out so you don't get lost. You're still pretty new to this. Okay, so what we're going to do is we're going to take this and plug it in here. So we get x plus h raised to a 4th minus x to a 4th all over h. Once again, we're taking the limit. We can't apply the limit yet because we have division by 0 if we do. Now, we can do a binomial expansion right here. So I'm going to do Pascal's triangle method. Use this. So I get x squared, so 1, 4, 6, 4, 1. We get x to the 4th, x cubed, x squared, x, no x, and then I get h to the 4th, h cubed, h squared, h, no h. Add those together. And then I'm going to bring down my negative x to the 4th. And then this is all over h. So what I did is I just took x plus h, multiplied it by itself 4 times, but there's a technique using Pascal's triangle to find that, so I used that. Okay, this is just like positive x to the 4th, this is negative x to the 4th. And then all of these are just kind of separate. There's like not much to do. Okay, so the nice thing is they all have an h in common. So I'm going to take out an h. Then I'm left with 4x cubed and plus 6x squared h plus 4x h squared plus h cubed. And then that's all still over h. So I just reduce the h's on each of them. Okay, now these x's will cancel. Now I can apply the limit as h approaches 0, which if that's a 0 goes away, that's a 0 goes away, that's a 0 goes away. So we're just left with 4x cubed. And so that's our derivative function if our original function was that. Okay, and that's it for this video. If you need additional help, come to MATLAB. Until then, calculator.